I am Annapurna. We are the students of GMU University, Davangere, studying BTech in CSC third sem. Today, we are presenting a topic from operating system. The code is UE23CS2306. Assignment 2, parallel sorting with child process Windows Unix environment. With this demonstrates efficient sorting of a large dataset by leveraging parallel processing. The program splits 10 million random integers into smaller subarrays, sorts them simultaneously using child process, and merges them into a single sorted array by using shared memory of inter-process communication and optimizing the merging process. This project highlights the advantages of parallelism over traditional single process sorting in terms of performance and scalability. Now, the code will be explained. The code will be explained. The purpose is to define the constants for the program. Array size, the total number of integers in the dataset, that is 10 million. Num children, the number of child processes to create, that is 10. Child array size, the size of the subarray. Each child process will handle 1 million integers per child. The purpose here is again to declare the helper functions used in the program. Generate random array. This fills the array with random integers. Merge array. This combines sorted subarrays into a single sorted array, and then allocates memory dynamically for the main array to store 10 million integers using malloc. Calls generate random array to fill this array with random integers. Create file mapping creates a shared memory object for inter-process communication. The parameters are like invalid handle value, page read write, array size, star size of int. So invalid handle value, this has no file in backing the memory. It's purely in memory. A page read write, this will allow both read and write access. Array size, star size of int, size of the shared memory region, 10 million integers, and the error checking is checks if the shared memory creation was successful. MapViewOfFile, this is the maps the shared memory into the addressed space of the process. Copying data copies the main array to the shared memory using MapCopy, and the again process information. This will store information about each child process. Startup info. This initializes the child process settings. Command line arguments like sprintf. This formats the command line arguments for each child process. I star child array size. This is the starting index of the subarray for the child. Child array size of the subarray, that is 1 million integers. Next example argument, child program.exe is 0, that is 1 million for the first child process. Then CreateProcess spawns the child process to sort its assigned subarray. The parameters are child program.exe, the executable file for the child process. Then command args, that is cmd-args. This argument specifies the subarray details. Then wait for single object. This ensures the parent process waits for each child process to finish. Infinite, the blocks indefinitely until the process complete. Close handle releases the resources for each process and thread handle. So the C program demonstrates how to distribute a large array processing task across multiple child processes using shared memory in Windows. The concise breakdown here is array generation. A large random array of size 10 million is created. Shared memory setup. The array is stored in a shared memory region using CreateFileMapping and MapViewofFile. So enabling data sharing between processes. And child process creation, the program forks 10 child processes using CreateProcess. Each child reviews a segment of array to process passed via command line arguments. Synchronization, the parent process waits for all child processes to finish using wait for single object. This approach allows parallel processing while leveraging shared memory for efficient inter-process communication. Thank you. And the further information will be given by Kaustuba.
I am Kaustuba from GMU, and today I'm going to discuss about the child process. And the C program is designed to access a shared memory segment, sort a specified portion of integer array within the shared memory, and then clean up the resources. Here break down resources, and here is a breakdown of the code shown on the screen, and let us start with the include header files, uh, which is include window, which includes a specific function for memory management, and standard IO function, and then the standard library including for those allocation and the conversion, and the function declaration is showed here is the sort array, which declares a function to sort the array segment, and then the main function is main function checks it checks if correct number of command line arguments, like start index and size are provided. If not, it prints the usage instruction and exits. And next, parameter phrasing convert the provided argument to integers, and the start index of array starts the index of the array segment to sort, and the array size is number of elements in the segments, and then shared memory access uses the open file mapping to open the handle to existing named shared memory object called global ash slash shared memory. And then if unsuccessful, it prints an error message with error code and exists, and then maps the shared memory into the process address space using map view of file. And then if file fails, it prints the error message, closes the handle and exits. And the next, array segment sorting calls the sort array to sort the specified segment of the shared array. And then resource cleanup unmaps the shared memory views and closes the handle to the shared memory object. Then the sort array function uses the C standard library function qsort to sort the array segment, and then the comparison function is provided as a lambda expression, uh, here shown in the code. And this lambda casts the void pointer to int pointer and returns the difference, determining the order of elements. And then the important consideration of this code is that error handling. The program checks if the error when opening and mapping the shared memory and ensures the robustness. And next, shared memory synchronization. The program assumes that no other process will modify the shared memory segment during the sorting operation. In multiple process environment, synchronization mechanism, that example mutexes, should be implemented to prevent the race condition. And lambda expressions with qsort uses the lambda function with qsort, is non-standard and may not be supported by all compilers. Uh, and the C standard qsort function expects a pointer to comparison function and not a lambda. And then moving on to shared memory object naming. The shared memory object is named global slash shared memory is a global prefix, allows the shared memory to be accessible across all sessions, and ensures that the shared memory object is created by another process before running this program. And sorting function, the qsort function is a standard C library function that performs a qsort on an array, and it requires a comparison function to determine the order of elements. And finally, this program is useful in scenarios where multiple processors need to access and manipulate the shared data concurrently. Proper synchronization and error handling are crucial to ensure the data integrity and program stability. And that's it. Thank you. Further will be explained by Vinuta.
To explain by code. The code you provide is a function that appears to part of a larger program designed to merge multiple sorted array. Let's break down the code step by step. Function merge sort array. This is the main function that takes three arguments. Array, an array of pointers where each pointer points to a sorted integer array. Number of array. The number of sorted arrays to be merged. Result. A pointer to the array where the merged sorted result will be stored. Size. The size of the each input array and the size of the result array implemented placeholder. The function currently contains a placeholder comment implemented merging logic here. This indicates sorted array as not at been implemented. The merging logic could typically involve iterating through the input areas, comparing the element and selecting the smallest element. Generated random array. This function takes in integer array and its size as arguments. It populates the array with random integer values. Cleanup. The function appears to be responsible for releasing memory allocated during the program's execution. The purpose of the code is to merge multiple sorted array into a single sorted array. The merge sorted areas function is the core of the operation, but the merging logic itself currently missing. The other function generate random area and cleanup provides supporting functionally. The placeholder in merge sort array needs to be replaced with the actual implementation for merging the sorted array. Next will be continued by Chandana. Thank you.
Hello everyone, I am Chandana. Today I am here to discuss about the performance measure of this assignment. This assignment demonstrates the use of parallel sorting technique using the child process in a Windows environment and explores the Unix equivalent implementation. The program achieves efficient sorting by dividing a large data set of 10 million integers into smaller subarrays, sorting them in a parallel and merging them in a sorted arrays into a final sorted array. By concepts such as process creation, inter-process communication, and shared memory management were applied, making the assignment a comprehensive exercise in the parallel computing. Now let us discuss about the performance measure of the parallel sorting and a single process sorting. First, parallel sorting. Sorting is significantly reduced by utilizing the multiple child process to sort subarray in a parallel. The use of shared memory via CreateFileMapping and a map file of view ensures the fast and efficient data transfer between the parent and child processes. Merging them is optimized using an efficient algorithm for combining the sorted arrays. Next, comparatively with single process, sorting the entire dataset in a single process takes considerably more time due to the sequential process of the data. Well, it is simple to implement, but this approach fails to leverage the multi-core capabilities of the modern CPUs. Some of the comparisons between the parallel and single process sorting is in parallel sorting, the execution time is reduced due to concurrent sorting by multiple processes, while it is longest due to sequential sorting in a single process sorting. Resource usage utilizes the multi-core CPU capabilities efficiently in a parallel sorting technique, while it is limited to single thread performance in a single process sorting. And complexity is higher due to the process creation and inter-process communication in a parallel sorting technique, while it is simpler implementation without any inter-process overhead in a single process sorting. By this, I'm going to conclude this that the parallel sorting demonstrates a clear advantage in executing time for a larger data set, especially on a multi-core system, as it divides the workload among multiple processes. The use of shared memory for inter-process communication in a window or in mmap in that is Unix ensures the efficient communication and the data sharing, while the complexity of implementation increases with parallelism. The performance gain for larger scale sorting tasks makes it a valuable approach in computationally intensive scenarios. This project highlights the importance of understanding the system level programming and leveraging the hardware resource for optimized performance by giving a better performance by decreasing the time complexity. Thank you all.